Welcome back. Today we're looking at MAAP Algebra 1. We're doing practice set 2, and I am going to take you through 5 of the items on their practice test on the official website, showing you how to use the Desmos graphing calculator on those items. And then you can use the strategies I'm showing you today on a practice set that I just put out for free in my store. I'll tell you more about the free practice set at the end. The first thing you'll do is go to the official Mississippi Academic Assessment Program practice site, and they do have some sample items and practice tests for you to use. Where it says select test, you will choose math. Under grade, you will select Algebra 1. And for the test, we are going to do a practice session, so choose that. Scroll down and click on the button that says Start Test. You can click Continue. And X here if you want to skip the tutorial. Click Start Test. Now there are 60 items on the test, and we are not going to look at all 60 items. We're going to choose 5 today to look at. The first item we'll look at is item number 3. You can get there by clicking the blue arrow on the top right, but I'm going to show you another way to jump directly to an item. Click on Review, choose item number 3, and it'll take you straight there. So in this question, we have a function g of x represented by an equation, and we have another function h of x represented by a table, and we're asked to compare the two functions and choose the statement that is true about in the two functions. So the first thing we're going to do is pull up our graphing calculator, which is a button at the bottom of the screen. I'm going to move this over. I'm going to resize it. And then I'm going to put in my function g of x, which was the equation that was given. Now the next function that I'm given is a table. So I'm going to go ahead and insert a table by clicking the plus sign on the top left of the calculator and then choosing table. And then I'll just duplicate this table. Once these data points are in, you can see the shape of a parabola taking form over here to the right. We probably have enough information to answer the question without doing what I'm about to show you, but I do want to show you an option that you might have. First of all, click on the plus sign for Zoom Fit, and that will fit the graph to the data if it's not already fit. It looks pretty good in this case, so I don't know if that's even really necessary. I think that looks pretty good. But another thing you can do is go down to the next row and type in a regression equation for quadratics. This is not something kids in Algebra 1 have to know how to do, but it is sometimes helpful to create an equation to connect these points in the graph that were given in green. All right, so Y1 is the first thing you type because that's the title of the column on the right side of this table. And then tilde. Tilde is to the left top of your keyboard, right under your escape key. You'll need to type shift and then that key. Then you'll type AX1. You don't need to type a subscript or anything. Just type a 1 and it will subscript it for you. Type shift 6 and put in a 2 for your exponent. Arrow to the right and type plus BX1. Arrow to the right and type plus C. And what you'll see here is that we have now connected the dots on our the points that were in the table. You don't need it really, probably, but it's a good strategy to use if your kids are comfortable typing in a regression equation in the calculator. And then, of course, you can just retype the equation below if you want to, or just use the one that's in the graph. So the question says, and let me shrink this down a little bit, which is true. Now my function g is red and my function h is black. If yours are the same color, you would want to press and hold and change the color of this equation to be different so that they could really tell them apart. The graph of the function g of x, which is your red one, has a higher maximum value but a lower y-intercept. Okay, well, let's see if that's true. The maximum value on this graph is 7, and the y-intercept is -2. The maximum value on this graph is 4.25, which is lower, and it has a higher y-intercept of 0.2. So it has a higher maximum value, the red graph, g of x, but a lower y-intercept, and that is a true statement. The other answer choices quickly are the graph of g of x has a lower maximum value. Well, we know that's not true, so we can eliminate B and C. And the graph of function g of x has a higher maximum value and a higher y-intercept, and it does not. So the correct answer was A. The next question that we're looking at is question number 5. We're given a formula for the vertical position of an object, and we are given some values to plug into that formula, and it will give us a quadratic equation that we can use to answer this question. So the first thing I'm going to do is pull up my calculator. Now you can type the equation exactly as it appears if you want, or I'm just going to use h of t because I'd really like to have a function of t here. So let's just do that. So 16t squared plus vt plus c. Now it's saying add sliders, and that's because we don't know what v and c are. So I'm just going to click on all, and it will add sliders. Now I know the values of these because it's given to me in the text, so I'm just going to type those in. The first thing it says is the object is launched upward from a height of 160 feet, and then we're told the initial height of the object is the C. So we're going to go ahead and let this C, I'm going to type over it, 160 feet. Okay, the next thing we're going to do is type in V, which is the velocity. The velocity of the object is given as 96 feet per second. So we're going to type 96 here. Now I'm going to go ahead and pull this out so we can see it better and bring it out here. And this is a terrible window. So my suggestion is to put in a table and start at 0. And I'll put a few points and we'll see what else we need. So I'm going to go up to maybe 5. These are representing your time in seconds. And then I'm going to do h of x1. Now, the reason I'm not typing a t is because the column on the left side of the table is x1, and I want it to substitute in those numbers in the first column. And so here you can see the numbers. And what I tell my students to do is to continue typing these until it gets to the 0 or until it gets to a negative. And so at 8 seconds, it's at a negative. I'm going to stop there. So let's see if we can answer some questions. If you'll click on the zoom fit now, you should be able to see the graph really well to answer the questions. So it says fill in the blanks with the appropriate values. Okay, at blank seconds, the object's maximum height will be. Well, in your table and on your graph, the highest point is the vertex of the graph, and it will be 3 and 304. Now, it's important for them to make sense of it. The time is in seconds, and that's going to take 3 seconds. I generally tell my kids on the vertical motion formula problems, lower numbers are usually your time, and higher numbers are usually your height. And that is true in this case. So 304 would be your feet, and that's all there is to that. The next item we'll look at is question 13, and this is an inequality that is graphed, and we are choosing 2 answer choices that are solutions. Your students do have to know solutions are in the shaded portion of the graph or on a solid line. This is a dashed line, so none of the points on the line will represent solutions. Let's go ahead and type in our calculator the ordered pairs. Now we can't get that line on here I mean, we can write an equation for it, but a lot of students struggle with that anyway. So what I'm going to do instead is try to recreate this graph as best I can. So I'm going to label the x-axis with an X and count by ones. And I'm going to label the y-axis. Let me see if I can get this to go to -10 to 10 and count by ones. If it'll let me. And I don't have grid lines, and I do want zoom square. All right. So what I'm going to do, and it's not really liking these, it doesn't want to give me those grid lines, but let's see what we can do instead. I'm going to go ahead and graph -3, comma, -8 is an ordered pair, and I'm going to label that in the graph. So the question is, even without grid lines, let's see if I can get them to show up. Maybe if I spread this out. There you go. All right, so I've spread it out a little bit. It's working a little better. -3, -8 is down here in our third quadrant. And obviously everything in the third quadrant here is shaded. So -3, -8 would be a solution. So I'm going to go ahead and check that one. On the next row, I'm going to type 0 and then 11/4. And 0, 11/4 is located just below the 3. Now, I would say that one's probably not a solution because it's looks like it may be on that line. So I'm going to go ahead and wait on that one and see if there's another one that's more obvious that's a solution. So we'll do 210. I can't even see 210 on the graph, but it's way up there. So that one is not going to be a solution because 210 would be all the way to the top of the graph on the screen. Next is 32. And notice how I'm clicking label, and it's labeling the point so I can get a good look at it. 3-2 appears to be on that line. So I'm going to say 3-2 is not. So let's hope this last one works. The last one is 4 and 3/2. 3 divided by 2 is how you can type 3/2. All right, so 4 3/2. Now 3/2 is actually halfway between the 1 and the 2 on the y-axis. So at 4, if you put a point halfway between the 1 and the 2, that is in the shaded region. So of the choices that we have, I'm going to take these off. The two that are going to work are going to be -3, -8, which we've already said, and 4 3/2. The next item we're looking at is a function to represent a sequence. Question 14. Pull up your calculator, move it over, and let's pull this out. The first thing I'm going to do is type in my first answer choice. So f of x equals 2 times 4 and raised to the x minus, and unfortunately, look what that's doing. So to get your exponent to stay up there, let's enclose the x minus 1 in parentheses. So that's what it should look like. Now on the next row in the calculator, I'm going to insert a table. And in the table, since this is a sequence, we're going to use a domain of positive integers. 1, 2, 3, 4, 5 is probably plenty. Let's see. 1, 2, 3, 4, 5. Yeah, there are exactly 5 numbers in our sequence. So 1 through 5 should work. Now for y1, we're going to take that out and actually use f of x1. And that will take the numbers 1 through 5 and replace the x in the equation with 1 through 5 and give us our values out. And you will notice that this is actually the correct answer. So the correct answer, the function that represents this sequence, is answer choice A. The last question we'll look at is question number 16. And here we are supposed to multiply two polynomials to get a third polynomial and then choose the correct answer from there. But we're going to use our graphing calculator to find an equivalent expression by examining graphs. So I'm going to open my calculator and type in my original product And then I'm going to compare this graph to these answer choices. Now, right off the bat, you'll see this window is pretty bad. I should see more than just a vertical looking line. So let's zoom way out and we should see more of it. It does cross the axis at 6. You might notice the y-intercept is -24. Those are really the only things you're going to need to figure out which of these works. So I'm going to just kind of look at those, and then we'll type in our answer choices. So the first answer choice is 2x squared minus 2x minus 2. Unfortunately, that's the same color as the original. So to change the color, click and hold the dot next to your equation and select some other color. I think I'll do green. So you will quickly see that this graph is a parabola, and the function, the product that we first typed in is not a function, is not a parabola. It's a cubic function. So A is not correct. So let's go ahead and look at B, but we probably shouldn't because it's going to be a parabola too. So that one doesn't work either. So let's type in C. So this one's 2x cubed. So now we're getting something that's cubic, which is a little more similar. Okay, and then I can see two distinct graphs here. So this also does not match the original. So it must be the last one. Let's change this -3 to a -15. We'll change this +4 to a +22. And we'll change this to a -24. And then all of a sudden you can't see the red one anymore. If you'll click this dot, it will turn off the green graph and you'll see the red graph. Click it again to turn it back on and you'll know they are the same graph. So the correct answer to question 16 is D. So if you haven't checked out my store yet, I encourage you to do that. Head on over to the store. The link is in the show notes, so just scroll down to get that. And if you want a copy of the practice set I created to mirror the items you just saw me work, go to My Products, and where it says Best Sellers, choose Most Recent. And it's going to open up my practice set. One, this was last week's. This is no longer free. It's a paid item. But today you have a new practice set in here, practice set 2, and it is free. It will continue to be free until next Monday. So that will be, I think, March 11th. So let's go ahead and get that. If you haven't already downloaded it, go ahead and do that now to get your free copy. Now, when you get in here, you can kind of see what's in it. There are 10 items. I just worked 5 today, but there'll be a second video coming probably tomorrow with the other 5 items so you can see the strategies that you could use to work those. The purpose of this practice set is for your students to practice the skills I just showed you, to use that Desmos graphing calculator to either check their work or to actually work the item, whichever they need. And these items do mirror the actual items that are on the official practice site. I did write a lot of these items. It's kind of interesting. I had not looked at this site in a couple of years because I taught in Indiana last year. But the year before, I taught in Mississippi. And for several years, I worked on the committee to write items for the MAAP test. And I was kind of surprised that quite a few of my items showed up on both the released items and in this test too. So quite a few of these I actually wrote myself. It was kind of interesting. They did tweak some of my items and make some changes. So I took that to heart when I was creating your items and tried to mimic the things that they did on their items. There are 9 pages in here, and it does include an answer document. Feel free to digitize this test. And what I mean by that is you could use a Google form or some other online service, and there's so many out there now to scan for the kids to put their answers in so you could grade this instantly. But I did provide a paper answer document because some people just prefer that to work on actual paper, so you can do that. If you have any questions about any of these items or have some suggestions for upcoming practice sets, something you really need for your kids, please let me know because I'm always looking for new projects to work on. Y'all have a great day.